Afternoon class. Today we shall be talking about matrices. This is from pre-work matrices. And students, by the end of the lesson, you must be able to do the following. Number one, you must be able to add the matrices. You must be able to add matrices. It means that our first objective is addition and subtraction of matrices. This is our number one objective. Number two objective, you must be able to determine the determinant and the inverse of a matrix. Given a matrix, you must be able to determine its determinant and the inverse. So determination, determine inverse, stroke, inverse and or stroke, determinant. And the last objective for our class today is we must be able to use the concept of inverse and determinant to solve problems related to matrices. Solution of matrices. Solution of matrices. So these are our objectives today, and we shall be talking about this. So let us start with the first objective, number one, addition and subtraction of matrices. Addition and subtraction of matrices. Like in the case, let us take our example one. We're given matrix A is 3, 2, 1, 4, and matrix B is 2, 3, 4, 1. This is our matrix A and this is B. Then you are told find A plus B. If you are told to find A plus B, it is very simple. We will take the corresponding values, you add. Corresponding values, you add. Like in this case, let us write down A. Let us write down the matrices of A. We have 3, 2, 1, 4, plus the matrices of B are 2, 3, 4, 1. So then this corresponds to this and this corresponds to this. In other words, you will add the values which are corresponding. By so doing, we shall have found the solution to that matrix. So we had 3 plus 2, so 3 plus 2, 3 plus 2, then 2 plus 3, 2 plus 3, then 1 plus 4, 1 plus 4, then 4 plus 1, 4 plus 1. 3 plus 2, this is 5, 1 plus 4 is 5, this one is 5, this one plus this one is also 5. Then we have A plus B is 5, 5, 5, 5. This is what we have. Now, let us look another example. Supposing we are given find 2A plus B. Given that A is matrix 3, 2, 1, 4 and B is 2, 3, 1, 4. So find 2A plus B. We will write 2 into A. Matrix A is 3, 2, 1, 4 plus matrix B is 2, 3, 4, 1. So then we will multiply these two by everything inside the bracket. So 2 times 3 is 6, 2 times 2 is 4, 2 times 1 is 2, 2 times 4 is 8, plus 2 plus 3, 2, 2, 3, 4, 1. Then we can now add this. Originally, you are not able to add this before multiplying. But now we are able to add because we have already solved the bracket. So we can add the corresponding values. 6 and 2 are corresponding. Of course, 8 and 1 are also corresponding. So 6 plus 2, 6 plus 2, then 4 plus 3, 4 plus 3, 2 plus 4, 2 plus 4, and finally 8 plus 1. So we have 6 plus 2 is 8. This one plus this is 6. 4 plus 3 is 7. 8 plus 1 is 9. This is matrix 2A plus B. So this was our example 2 in this case. And this is our example 1. Example 1 in this case. Now, this is all about addition of matrices. Let us look at subtraction of matrices, because our number one objective was addition and subtraction of matrices. This here we are given if matrix A is 3, 2, 1, 4 and matrix B is 2, 3, 4, 1. Then we are told find A minus B. Find matrix A minus B. This is very simple. Like in the case of addition, we do it similarly. 3, 1, 2, 4 minus B. 2, 3, 4, 1. But remember, this and this are corresponding. This and this are corresponding. This and this are, so does this and this. So you take the corresponding values and work with them differently or independently. 3 minus 2, 3 minus 2, 2 minus 3, 2 minus 3, 1 minus 4, 1 minus 4, then 4 minus 1, 4 minus 1. So we have 3 minus 2 is 1, 2 minus 3 is negative 1, 1 minus 4 is negative 3, 4 minus 1 is 3. Then we have matrix A minus B. This is our answer in this case. Now, the addition and subtraction of matrix, this is how we will attend to it. Now, let us see a solution number 2. Determine the inverse. We are going to work on how to determine the inverse and the determinant of matrices. This is our objective 2 for today. Let's look at that very fast. Simple as mathematics. Now look at this. Number 2. The objective number 2 is determining the inverse and the determinant. Now, if this matrix is given, this matrix A is 3, 4, 5, 6. Then somebody tells you, number 1, determine the determinant. How do we find the determinant of this matrix? We find this determinant of a matrix is leading diagonal minus minor diagonal. You see, if you're given this one, the leading diagonal is this one, and the minor diagonal is this one. So the leading diagonal is 3. 3 times 6 minus 5 times 4. 5 times 4. In other words, this is major diagonal or leading diagonal minus minor diagonal. This is major diagonal, 3 times 6, minor diagonal, this one times this one. So 3 times 6 is 18 minus this one times this one is 20. So then the determinant in this case will be negative 2. This is our determinant. This is how to find the determinant of a matrix. Now, let us look at the inverse of a matrix. We want to look at the inverse of a matrix. Inverse of a matrix. Now, in this case, if we are given a matrix is given by, we are given matrix 3, 4, 5, and 6. Then somebody tells you, find the determinant of this matrix. Find the inverse, the inverse. The inverse of a matrix is equal to 1 all over determinant into, inverse of a matrix is 1 all over determinant into, then you interchange the major diagonal. The values of the major diagonal, you interchange them. Then the values in the minor diagonal, you negate them. You will make them negative. You will multiply by negative. Now, like this is major diagonal. You will interchange these. If you interchange these, we have 6 on top now, 3 at the bottom part. Originally, 3 was at the bottom and 6 was at the top. And then for the major diagonal, for the minor diagonal, you will negate. So you will negate this. You will make it negative 4, and this is negative 5. But we have the determinant. Determinant of this one is this one times this times this one and this times this, which of course we found it originally it was negative 2. So this was our determinant. Because I already showed you how to get the determinant. Then 1 all over negative 2, which is the same as negative here, into 6, negative 4, negative 5, then 3. You can multiply everything here by a half, negative half. So this one will be negative half times 3. We will have 3 negative. Then here we will have 2. We will have here we will have 5 all over 2. Then here we will have 3 all over 2. This is our determinant in this case. This is our determinant. Or other, you can make this ones to be in decimal, so that this is negative 3, this is 2.5, this is 2, then this is 1.5. We have two negatives. This is a negative, this is also negative. This is a negative. This is a similar thing. So you don't need to worry about that. This is how we handle the determinant of a matrix. Let me do another example on determinant so that you can see what we have. Now, find the determinant. Find the inverse of the matrix below. Find the inverse of the matrix below. The matrix is 3, 3, 2. Then we have 1, 1. 3, 2, and 1, 1. This is the matrix. Maybe let us say this is matrix A. And then we find the inverse of matrix A. For us to find the inverse of matrix A, we first of all find the determinant. But determinant is equal to major diagonal minus minor diagonal. The major diagonal is 3 times 1, 3 times 1, minus minor diagonal is 1 times 2, 1 times 2. So we have 3 minus 2 is equal to 1. If now you have the determinant here, now let us work out the inverse. The inverse is equal to 1 all over determinant, but determinant is 1 into the diagonals. You will interchange the major diagonal. We will have 1 and 3, then you negate this one. We have negative 2, negative 1. If you multiply everything inside the bracket here by a 1, 1 over 1 is the same as 1. You will have 1, negative 2, negative 1, and 3. This is our matrix, the inverse of that matrix. Good. Having said that, let us take ourselves to the solution of matrices. The solution of matrices. Solution of matrices. Let us work on this other end now. I hope you are writing. I hope you are making some short notes on the end. Now, look at this. We have use matrix formula to solve x and y. Now we have the solution here is 3x plus 2y is equals to 5. Then we also have x plus y is equals to 3. X plus y is equals to 3. These are the two solutions we have. Then you are told, use matrix formula to solve the two. Number one solution now. Let us solve it. Solution number one thing. You must make these two. This solution, make them derive it in a way that you can derive a matrix formula. Write them in matrix form, or rather, write this in matrix form. If you write this in matrix form, you will write 3, 2. The coefficient of x here is 1, the coefficient of y is 1. Then we have x and y. Then we have 3 and 5, which is equals to 5 and 3. If you are writing up to this end, already you have 1 mark from me. If I was the marker, you have 1 mark. But anyway, we can continue with the same. What shall we find the value of x and y? It is very simple. Work out this, find the determinant of this, find the inverse, then whatever you will have, you multiply by this end, then you have your answer. Let us do it together. Let us do it together. We can do this together very fast. Now look, we have 3. Sorry about that. We have 3, 2, 1, 1, x, y, 5, 3. This, you are writing it in matrix form. Now let us solve this together. If you want to solve this value of x and y, find the determinant of the first matrix. The first matrix here is this one. Determinant of this one is determinant is equals to major diagonal minus minor diagonal. This is major, this is minor. So major diagonal is 3 times 1 minus minor diagonal is 1 times 2, which is equals to 3 minus 2, which is equals to 1. But now let us also find the inverse of this matrix. Inverse is equals to 1 all over determinant, but determinant is 1. 1 all over 1 into, you interchange the main diagonal, which is, this now will be 1 and this will be 3 after interchanging. Then we will negate this. This is negative 2 and negative 1. We can solve this together so that we have 1 times everything here. We multiply this one by everything inside the bracket. This one times this is 1. This one times this one is negative 2. The whole of h times negative 1 is negative 1. The whole of 8 times 3 is 3. Having done this, now multiply by everything here. Then you shall have found the values of x and y. You shall have determined the values of x and y. Let us do it on this other end so that we can be able to see it clearly how it is derived or how it is done. Now look, we have 1, negative 1, negative 2 and 3. It is this one. So then you will multiply it by this, the other end. Then by solving, you shall have calculated or found the values of x and y. This is 5 and this is 3. Now, most of you have problems in multiplying matrices. Multiplying matrices, I will handle that as we progress. So this is 1 times 5. 1 times 5 plus negative 2 times 3. Negative 2 times 3. Let us go to the down part. Negative 1 times 5. Negative 1 times 5 plus 3 times 3. 3 times 3. 1 times 5 is 5 plus negative, this one times this is negative 6. And this negative 1 times 5 is negative 5 plus 9. If you solve this, you will find that 5 plus minus 6 is the same as 5 minus 6, which is the same as negative 1. Negative 5 plus 9 is the same as, negative 5 plus 9 is the same as 4. It means that the first value here is represented by x, and the second one is represented by y. Therefore, our x is equals to negative 1 and y is equals to 4. Even if we use both substitution and elimination methods, you will find the values of x and y to be negative 1 and 4 respectively. And that marks the end of our lesson today. Students, you keep on revision. If you don't revise, you're not guaranteed success. And you have a good. Don't forget to subscribe to our channel, like and drop a comment. Thank you and